Hey everybody! The purpose of this video is to walk us through a potential solution to 2.13.11 in the Collaborative Statistics textbook. This is a fun one. We've got a box plot that looks kind of different than the ones we've looked at before. You've got the box and a whisker, but no whisker over here. So working kind of backwards, we can kind of reverse engineer what we're looking at. Here's your maximum value. Here's your third quartile, your upper quartile. Here's your median. And then you get down to here and you figure, okay, well that's the box. So the box has to have the quartile, lower quartile be at the far side, the far left side. Well, where's the minimum value? Well, it just turns out that since there's no whisker visible, the whisker must be contained right on that line. More on that in a second. So, Part A says, think of an example in words where the data might fit into the above box plot. In 2 to 5 sentences, write down the example. Okay, as far as an example of this, you could maybe be testing the distances traveled by, say, a new toy rocket. I'm thinking of my son. I'm looking over and seeing a picture of my son right now on the wall. And he has these stomp rockets, you know, and I might collect data, which is him stomping on the stomp rocket and him trying to figure out what's the best possible way. What's the best possible way to hit these stomp rockets? And this might be a new strategy that I'm trying out with him. Okay, let's put the angle at a certain 46, 47 degrees. Let's be realistic, basically like this, and then jump with both feet up and hit the stomper. And let's see how far the rocket goes. Okay, so let's say he does this 12 times. Let's say he does this 12 times. And let's say the data that we have, and this is in feet traveled horizontally. Feet traveled horizontally. He's got 3 that don't go anywhere. A 4th one does not go anywhere. Then he gets one that goes 15 feet, one that goes 17 feet. Then he gets one that goes 23 feet, and then he gets a few that go, say, 25, let's say 50. Let's say, what's your upper quartile's about 100, right? So what are we up to? We're up to 50. Say the next one goes, let's see, 50 to 100. Oh, we should make it go 50. Let's make it go 90. And then he's got one that goes 110. It's getting a little ridiculous now because these things don't go more than 12 feet. But 110, and then finally, say, 130 and 150. Now, whether or not you like the context of my example, which granted is off the cuff and a little bit ridiculous, that data would fit that box plot pretty well. If you check out where the median is, it's an even data set of 12 data points. The median's halfway between 17 and 23, which would be 20. So that means you've got 15, 17, and 3 and 4 zeros all contained in this little range here. You also have the 23, the 25, and the 90 in this box. The 110 over here, the 100 is the median between 110 and 90, right there. 130 and 150. What's interesting is that if you identify where the medians are, here's your Q2 between those guys, here's your Q3 between those guys, that's a 110. Here is your Q1. Well, unfortunately, that's also your min. And that's why you see this. Your min is equal to your lower quartile. When your min is equal to your lower quartile, you're going to have a box plot that looks something like that, which is pretty slick actually. So part B, what does it mean to have the first and second quartiles so close? Oh, excuse me, we're getting ahead of ourselves. So anyway, that's one particular data set where it could happen. Say you're checking very, very variable data, extraordinarily variable data, and you just get a whole bunch of zeros. Well, the lower whisker is going to appear to disappear because it's fallen off the charts, but it's really just overlying the quartile. In part B, what does it mean to have the first and second quartiles so close together, but the second and fourth so far apart? Now that's an interesting, second and fourth. There's no fourth quartile. I guess the fourth quartile would be the max. So I was going to say second and third, but we'll say second and fourth. So all it means is that the lower half of the data is less varied than the upper half of the data. I can't calculate standard deviations in my head. I sure can't do any kind of precision on averages in my head either. But you can tell by looking. The variability from these data points here is far less than the variability of these data points here. And that's indicative in the spread of the boxes. Okay? So hope that helped.